This video I wanted to show a couple quick examples on how you graph piecewise functions. Use your TI-83 or 84, 84 plus calculator. So I got a couple examples here, and I wanted to show you. We got f of x equals x minus 5, where x is less than 0, or negative 1 half x plus 3, where x is greater than or equal to 0. When you plug these into your y equals screen, as you can see, I have the y equals screen open up over here. You need to separate the rules here for your piecewise functions with parentheses. So you're going to have to put parentheses around each function and rule and separate them with a plus sign. And I'll show you here in a second on the right with the calculator on how that works. So doing so here, I have my y equals screen open, and I'm going to go parentheses x minus 5 and close the parenthesis, and we're going to multiply that. We're just going to butt it up to another parenthesis right here, and x is less than 0. So now to get the inequalities, right above the math button is that test button right there. So I'm going to hit second math, it gives you the test button, and here's all your inequalities right here. I needed less than 0, so I'm going to choose number 5. So less than 0, close the parenthesis. So there's the first line of the piecewise function, and I'm going to go plus and add the second line. So I'll go parenthesis, negative, and then for the fraction bar I'll hit alpha F1, and that gives me my fraction bars, or you can just put negative 0.5 as well. So 1 half x, and then plus 3, close that off, and then parenthesis x is greater than or equal to 0. So second test, greater than or equal to is number 4 right there. And then 0, close parenthesis, hit enter. And now I'm just going to go up to graph, and I should see right here that I got two lines that are split right here at 0, which makes sense because that's where, if we're less than 0, that's to the left of the y-axis. We know we have x minus 5. There's a y-intercept of negative 5, and then negative 1 half x plus 3 for the numbers that are bigger than 0. So that's a negative slope, so that's why it's leaning that way with a y-intercept of 3. So that was a two-part piecewise function. Now I want to take a look at this next one here. We have a three-part. So we have a quadratic, and then a constant function, and then another quadratic. So to plug these in, I'm going to do the same thing over here. I'm going to make sure that I put parentheses around the rules and put a plus sign and do the same thing for all of these. Now this second one right here, we have to put this in a little different because you got a compound inequality. So if I split these two up and write a compound inequality, that first part I've got x is greater than or equal to negative 3, and the second part, x is less than or equal to 2. And this right here is how I'm going to have to put this in. That's how I'm going to have to put that in right there when I go about putting it in the calculator. So let's take a look on how that works out. So the first one was x squared plus 6x plus 11. And the rule was for x that is less than negative 3. So x, second test, less than was number 5 there, negative 3, close parenthesis, plus. Then the next rule, the next line is parenthesis 2, constant function. And here's where we have to put in the compound inequality. So I got x is greater than or equal to negative 3. So x, second test, greater than or equal to, it's number 4 there. And then that's negative 3. Now, to get the word and, I'm going to go back to the same menu, second test, but I've got to scroll over one to logic. And the first choice is right there, and. And then I can put the second one, x is less than or equal to 2. X, second test, less than or equal to is number 6 there. And 2. Close that off. So that's how you get the compound inequality there. And then I'm going to do plus again because I got a third rule. So this piecewise split up into 3 parts. So parenthesis negative x squared plus 4x minus 8. Close that off. The rule is x is bigger than 2. So x is greater than 2. close the parenthesis, hit enter, and keep your fingers crossed here. Let's see how this looks. We should have a parabola coming down. We go constant straight across, and then we have an upside down parabola right there. So there's your piecewise function on how you can plug those into your TI-83, 84, 84 plus, and so on. That's how you can get a visual graph of a piecewise function. So hope that helps.